Hi HMS modelers, this is Matt Fleming and I work at the Hydrologic Engineering Center, and in this video I'm going to talk about useful GIS data sets that you need to gather and process in order to use the delineation tools that are available in HEC-HMS. Alright, let's get started. Alright, so types of useful data sets, and I'll start at the bottom of this slide and then talk about required. So useful data sets. So in HMS within the basin model map, you can load any type of shapefile. So as long as that shapefile has a projection that matches the projection of the basin model, then those GIS elements are going to be displayed on top of the subbasin, reach, and other elements defined within that basin model. And so types of GIS data sets that hydrologic modelers should gather include the National Hydrography Dataset, NHD dataset, and that provides you with published stream information, so digitized streams across the United States, and also digitized watersheds can be gathered, or they are part of the NHD dataset. Also, if you have gauge locations, so precipitation gauges, stream flow gauges, you want to create your point shapefiles that contains that information so you can display that on top of your basin model map. And then that's what you can see in this figure right here. I have these diamond elements right here. These represent precipitation gauges in the watershed. And then you have this one element right here. If you squint your eyes at the lower portion of the basin model here, that represents the stream flow gauge location. If you have reservoirs, then you could load those reservoirs as polygons and display them within the basin model map. If you have land use information, soil information, you could load those as ASCII files, display that information in the map, or as in the other videos are going to show, you could use that information to estimate your basin model parameters, or specifically the subbasin loss parameters. And then other information too, if you're going to link HMS output to another model, like a HEC Resim or HEC RAS model, then you might want to load some type of geographic information inside the basin model so that you know where you're going to provide that handoff of data to another HMS model. So those are helpful GIS data sets that you have to have defined within your basin model. In order to use the GIS delineation tools, you have to have a terrain data set. All right, so let's talk more about the terrain data set. Oh, before we do, we can talk about the tools that are available for displaying these background either shapefiles or terrain data sets. There's a map layers editor. So this is available from the view menu. You open the map layers editor, it's going to look something like this. It's going to show you all the map layers that have been defined in the project. If you want to add more shapefiles to the basin model, you simply click the add button right here and then navigate to where that shapefile lives on your computer. You can remove them and so on. As you run through the GIS delineation tools, you're going to notice that the output from those tools are going to be automatically added to the list of available map layers. And you'll see more about those in other videos. And then, as always, for any of these background map layers, you can edit the draw properties. And so here I have a point shapefile selected right here. This is the rain gauge shapefile selected. Here's the draw properties button right here. When you click this button, you're going to see an editor open that looks something like this. And you can change the style of those features. So you can choose a diamond or a square or whatever type of shape you want to use to represent those rain gauges, and then choose the color and then the size of those elements. All right, so let's talk more about terrain data. So for the United States, you're going to go to the USGS website and download the National Elevation Dataset terrain data. And so you have different options from this website. You can choose 30-meter terrain data, 10-meter terrain data, or even smaller 3 to 5 meter terrain data. And so one thing to note, or a couple of things to note when you gather this terrain data from the USGS, and here's the link at the bottom for navigating to their national map viewer, which allows you to identify the location and then the extents of the terrain data that you want to download. So whenever you do download that data to your computer, note that the elevation units are in meters. So that's for the entire United States. And then also the terrain data that you do gather has not been projected. It's unprojected terrain data. And so you're going to need to run through a few steps outside of HMS to process the terrain data before you start using it within the GIS delineation tools. All right, so let's talk through the steps that you need to follow in order to get the data ready to use within an HMS project. So for many applications, especially for those larger applications, the data set might be rather large when you download it from the USGS, and so you might get a couple of terrain tiles. So in order to use the GIS delineation tools, you have to mosaic those multiple terrain tiles into one continuous terrain data set. The second step that I have here listed is you need to project the terrain data into a common or agency-wide typical projection. And I'll show a couple of tools that you have available for that. The third step here is you need to make sure that the vertical units are in the same projection as the horizontal units. So if you reproject the terrain data to some projection that has horizontal units of feet, then you need to make sure that the elevation units are also feet as well. The fourth step here, this is really about saving file size and increasing the processing time. You want to extract the terrain data so that it's really just it's enough to cover the watershed, but not much more than that. And I'll show you a tool that's available for extracting the right amount of terrain data. And then you need to check the terrain data set to make sure there's no missing or null values within that terrain data set. And then finally, this is my suggestion, keep the file size below 200 megabytes for most applications. The GIS delineation tools in HMS can handle larger terrain data sets, but I've noticed that for most applications, the processing time is much shorter. You're going to get through the delineation piece of it much faster if you keep those file sizes lower or less than 200 megabytes. So let's go into a little bit of detail for these steps here. All right, mosaicing the terrain tiles. So I have an example right here on this slide where there's 6 terrain tiles for this area right here. You can see about 4 of them, but there's 6 terrain tiles here. And so I'm using ArcGIS. I'm using specifically the tools within the data management tools toolbox to take these terrain tiles and mosaic them to a new raster. So as long as you can find the data management tools toolbox, go down to the raster tools and then expand the raster dataset tools, and then you're going to get a dialog or editor that looks something like this that allows you to select the different terrain tiles and then choose an output location and then a name for the mosaic terrain data set. So that was that first step. Mosaic the terrain tiles to one continuous terrain data layer. The next step is projecting the terrain data set. So as I mentioned before, the data that you get from the USGS is unprojected. So here you want to use the tools that are available again in data management, projections and transformations, and then within the raster toolbox here, there's this option to project the raster data set. So you click on that tool, you're going to see an editor that looks something like this figure right here, where you choose your input raster, then the output raster right here, and then you choose the output coordinate system. So for those studies within the Corps of Engineers, most studies, you're going to want to use that standard MMC projection where it's the Albers equal area and then the linear units are in foot or feet. Okay. After you have the terrain data set projected, you want to make sure that the vertical units align with the horizontal units. And so in the example I showed in the previous slide, we projected it to a projection where the horizontal units are in feet. Well, now I need to make sure that the vertical units are in feet as well. And so I'm using the Raster Calculator option from Arc Toolbox. So under the spatial analysis or analyst tools, there's a map algebra toolbox, and then I clicked on or chose the Raster Calculator option right here, Once you choose the Raster Calculator option, you're going to get an editor that looks like this, where you build your algebra expression. So in this one, it's very simple. You choose your output raster right here, and then you choose the equation for converting those vertical units. So in this example, I'm simply multiplying the DEM, or the terrain data set, by 3.2808 to convert it from meters to feet. All right. In the next step, I'm going to extract the watershed, or just extract the terrain data for the watershed. I'm going to remove any of the terrain data set that's not needed to define the watershed. And so there's an option to extract by mask, and I'll show that on the next slide. But before you get to that, you want to create a layer that shows the watershed. And so what I like to do is buffer the watershed. And in this example, I'm buffering the watershed by 1 mile. And so that's what you see in this figure right here. Here's my original terrain data set. And here is the watershed represented in the National Hydrography Dataset. It's in the watershed layer. Here's the watershed, and then I use the buffer tool to create a buffer of this watershed, and I buffered it by 1 mile. Okay, so now I'm going to use that buffered watershed to then extract by mask. So that's another tool available in Spatial Analyst Tools, Extraction, Extract by Mask. And so you choose your buffered layer. So the first thing you do is you choose your input raster right here at the top. The second step is the buffered data set, and that's going to be the mask. And so what the program will do is it's going to extract the terrain data that falls inside of that buffered subbasin polygon. And so what we went from is an original terrain file that was 446 megabytes to one that was now 26 megabytes after extracting just the terrain that we need to delineate the watershed. And then the fifth step here is removing those missing data cells. So I noticed this happened in the past with when working with the USGS terrain data. I have not noticed missing data in more recent times. But just in case, you can use the Raster Calculator to first identify if there are any cells within the terrain data layer that have missing values. And so you can use this very simple expression right here. It's a conditional statement. And so what you're asking the Raster Calculator to do, look at the DEM, or the terrain data set. If there's a null value or a missing value, then create a new terrain data, or a new raster layer, replace those null values with a value of 1, and then for all the valid values, use a value of 200 to represent those valid values. And so this is just a quick way to identify, are there any missing cells within that terrain data set? And then if there are missing cells, you could use an expression like this one. I'm sure there's other expressions out there, but this is a simple expression to, first we're going to identify those missing cells within the terrain data set, and then we're going to use the neighboring rectangle, so cells around those missing cells, come up with the mean of a 3x3 area, and use that mean of those neighboring cells to replace the missing cells. Okay. Once you've verified that all the missing cells have been removed from the terrain or filled in with values from the nearest neighbor, the last step here is to resample the terrain data set. And again, this is only if necessary. You only need to do this if your terrain exceeds 200 megabytes for most applications. But we have this figure right here is the resample tool, and that's going to be available from data management tools, raster, and then raster processing right here. All right, another really helpful data set, the National Hydrography Dataset. I mentioned this earlier. So NHD is going to contain your streams. So somebody has gone in there and digitized streams at different levels across the US using topographic maps. And then also there's other data layers in there that represent watershed boundaries at different levels as well. So you'll see HEC-12, HEC-8, HEC-4 subbasin polygons. And so you can see the definition of those subbasins based on somebody digitizing using terrain data sets or topographic maps. So I usually grab the National Hydrography Dataset for every study that I work on. You can gather that one from just the same location as you gather your terrain data, the USGS National Map Viewer. So you can go to that website. You can zoom into your watershed and then define the extents of the watershed, and the program will provide you options for downloading NHD layers for different areas or different watersheds. So you can download those to your computer. You can project them, same thing that you do for the terrain data sets. You can clip the information for your specific watershed if needed. You can use the National Hydrography Dataset to burn streams. So the stream layers, you can burn that information into your terrain dataset. Or also the watershed polygons, you can use that information and build walls within the terrain dataset too. And these are good options to enforce the drainage, so that if you do have to resample the cell size for the terrain, so if you go from 5 meters to 10 meters, 10 meters to 30, or 30 to 90, you can still use other GIS data sets like the stream layer and the subbasin polygons from NHD to impose the drainage pattern or drainage network onto the terrain data layer.